Section 7.2, Solving Exponential Equations and Inequalities. In this section, we're solving equations where the x is one of the variables in the exponents. For example, we have this first problem, 2 to the x power equals 8. And the goal here is to make the bases the same. The base is whatever the x is attached to, the exponent is attached to, I should say. So the base on the left side here is 2, because it's 2 to the x power. And we want to see, can we switch this so it's also something with a base of 2? All right, so you probably know already this is 2 cubed. If we did a factor tree, we would see that breaks down to 3 different 2's. So rewritten, this is 2 to the x power equals 2 to the third power, and we have it written like that. We can see that x just equals 3. Let's take a look at this next one. 3 to the x equals 81 to the fifth. Okay, again, we want to make this into the same base. So the base over here is 3. Can we turn that 81 into something that's base 3? Okay, so if we break it down into a factor tree, 9 and 9, then each of those 9 splits to 2 3's. So we have 4 3's if we take that factor tree all the way down to the bottom. Okay, so this 81 is really 3 to the 4th power. Okay, now we still have that 5 on the outside. Right, and at this point, we're going to multiply these exponents. Regular exponent rules here. So that becomes 3 to the 20th. So x is going to equal 20. Lastly, 2 to the 2n plus 4 equals 64. Base is 2. We want to switch this into something with a base 2. 8 and 8. Break them all down. Okay, and we can see that when we fully break this down, we have 1, 2, 3, 4, 5, 6 2's. Okay, so 2 to the 2n plus 4 equals 2 to the 6th. So this time we're going to end up with an equation. 2n plus 4 has to equal 6. Okay, because 2 has to be raised to the 6th power on both sides of this equal sign. So we come up with that equation. At this point, we just solve it. Subtract 4, divide by 2. X or n equals 1. Let's continue on. 5 to the 5x power equals 125 to the x plus 2 power. We have a base of 5. We want to switch this 125 to a base of 5. So we do a factor tree on it. We get 3 5's. And we're going to rewrite that 125 as 5 cubed. Now we have this x plus 2 as the power that it's being raised to. And we're going to have to multiply those two exponents. And that's going to give us our equation. So we have 5x on one side equals 3 times x plus 2 on the other side. Distribute, solve it out, and we get x equals 3. All those past exponent rules that we learned in the last chapter still apply. So if we have a number on the bottom here, okay, we can break it down with a factor tree just like these other ones. So we want to create a base of 3. So this is 3 to the 5th power, and it's on the bottom of the fraction. So it's really 3 to the 5th power underneath 1. And when we have an exponent on the bottom of the fraction, it just means that we can rewrite it as a negative exponent. So this 3 to the negative 5th is the same thing as 1 over 3 to the 5th. Okay, so we do the factor tree like normal. If it's on the bottom, we would just write it as a negative exponent because we want to have 3's as both of our bases. And that allows us to just take this exponent and solve it with that exponent over there. So 2x minus 1 is greater than, in this case, negative 5. Add 1, divide by 2. X is greater than negative 2. Lastly, okay, so here we have a base of 4. Here we have a base of 32. Oh, I'm sorry, here we have the number 32 on the bottom of a fraction. So if we break down that 32, we have 5 2's. Okay, we can't make it into a 4 because it's not a power of 4. 4 to the first is 4, 4 squared is 16, 4 cubed is 64. It skips over that 32. So what we can do is we can split up this 4 also. And we can turn it into 2 and 2. Okay, so now on the left, this 4 is 2 squared. And this 32 is on the bottom, and it's 2 to the 5th. So we're going to write it as 2 to the negative 5th. And that gives us our inequality, 2x plus 2, 2 times x plus 2, because we have to multiply them, is greater than negative 5. Distribute, solve it out, x is greater than negative 9 over 2.